Hi, I hope you've wrapped your head around the information in the first lesson and learned how Disney principles work in logo animation. Because you're going to need this knowledge in the two following lessons on morphing. This is the first theoretical lesson on using morphings in logo animation, and you're going to find out what morphings are and what they are used for in logo animation. What type of morphings there are, we'll cover them on specific examples, and how to create a good morphing. Let's start. Morphing is a transformation of an object into another. In the first example, the logo transforms into a TV and back. In the second one, the icons transform into letters. And in the third one, a character transforms into the final Facebook icon. Such tasks are extremely common in logo animation, as this is a brilliant and fast way of conveying a complex idea, and at the same time it is visually satisfying for the viewer. Here are more examples of good morphings in logo animation. They are created in different ways, but what they have in common is that we can't notice the moment of transformation, and objects seamlessly change into other ones. Looks cool. Unlike these animations here, the transformation here is too sluggish and draws the viewer's attention to itself, diverting them from the objects, which is not cool. There is an exception in frame-by-frame animation in which smooth morphing is used as a gimmick. We are not going to look at this technique in the lesson. Let's get to morphing classification and see how we can transform objects. Let's start with the replacement. The simplest and at the same time the most common way to turn one object into another is to use one frame, or replacement. That is a transformation in one frame. Let's look at its features on a small example. Let's examine this Apple into MTV logo transformation step by step. First, we've animated the position parameter of the first object, parented it to the second one, and replaced one with the other at some point. That is, we've created a common easing and a direction of movement. This is the first rule of good morphing. But this rule can't work alone. So our next step was to adjust the speed graph and make a replacement at the maximum speed. As at the maximum speed, it is more difficult for the human eye to notice the replacement. And this is the second rule of good morphing. We've added anticipation and bounces to make the morphing even more seamless. Anticipation in itself is a signal that something is going to happen. So any preparations for an action, like the square leaning to the left before leaping forward, immediately draw attention. And the viewer who has already been warned won't miss the movement, even if it happens lightning fast. As a result, the viewer doesn't have enough time to notice the replacement because of the speed and rotation, and looks only at the bounces. Bounces are tricky because they grab the viewer's attention, making them forget about the moment of transformation. This is the third rule. Add anticipations and compensating movement. We've also added distracting elements, and we've got this remarkable outcome. You have seen the work of these principles when animating position, but you can morph both scale and rotation in the same way, while keeping the object in one place. The rules are universal. Common easing, the maximum speed, anticipation, bounces, and morphing is ready. Let's analyze a few examples. Okay, first let's look at this morphing. There are a lot of elements here. Then there is a takeoff and a morphing when falling. Let's have a look at it frame by frame. You see that all the elements are morphing into letters when they fall. That is, at the moment they hit the ground. The bar morphs into M. It is simply replaced in one frame. You see that all elements have anticipation. They all have common easing. Also, all letters are replaced at the peak speed at the time of the impact. And of course, there is a compensating bounce movement, so the morphing is successful. Here we have a similar situation to that of the previous logo, but morphing occurs during a quick takeoff. But at the same time, there is anticipation and bounces, and everything looks pretty dynamic. Again, there is anticipation. Then a quick takeoff, and here you see, boom, replacements take place at the peak. The fastest speed is here, and then there's a smooth fade out, and so with all of the letters. Let's take a look at a more complex example, the animation of the Nexus logo. Here, the morphing occurs at the moment of an impact as well, but it has two different features. The first is that the shape and mass of the objects at the moment of morphing are as similar as possible, which makes morphing as unnoticeable as possible. This is usually done recursively. Take the final position of the logo, then go to the moment of morphing and adjust its shape as needed. And the second point is that not a single element disappears, just like that, but is replaced by a similar geometry and then animated further. This adds detail to the morphing, and overall it looks very cool. The same case in this example. The small details of the logo are maximally adapted to the shape of the character at the moment of the fall. Boom! Looks cool. Let's move on to the next type of morphing, changing the shape of an object. In many cases, the replacement alone will do. But if you need to smoothly replace one object with another, as here, you need to animate the change in the shape of the object from one to another. Usually, we are talking about animating the path property or the size property. Here's a couple of great examples. All principles of good morphing have been applied, and the morphings look perfect and seamless. Let's slow down the first example and have a closer look at it. You can see that all proportions have been preserved, and the morphing looks neat. You can observe the same on the second example, and the change of shapes is present almost everywhere. This is a very good example. And here are the examples in which there have been mistakes when animating path. Don't just copy a path of one object and paste it into another object. It looks uneven. Let's move on to the next type of morphing, splitting. Splitting is another slightly less popular but quite an effective form of morphing. This is a technique in which an object splits into several parts and then assembles into another object. This technique is often used in frame-by-frame character animation quite often, but it has found an application in motion design, and in particular in logo animation. Let's take a look at the features of splitting on the example of this logo and at what you need to pay attention to. Great morphing of Google. 4 points are morphing into the letter G and into the microphone. Let's look at some points separately in slow motion. The first thing I want to note is that the path and sequence depend on the design of the final element. The determining factor here is the color: red, yellow, green, and blue at the end. Note, the elements do not move at the same time, do not intersect, and do not turn into a mess, but rather follow each other and twist into one spiral, while always maintaining order. Also, note that the number of parts of the final element and the number of points are equal, which is also a great bonus. In the following example, you can also see how the bag splits into 3 ribbons, which twist into the final logo. We will recreate this animation in a practical lesson. Let's move on to the fourth type of morphing, overlapping. The overlapping method works like this. While one object is disappearing, the following one is revealed. Overlapping can be in the form of rotations in a 3-dimensional plane, changing the shape of the contour with a scale or position, or there are one or more elements that overlap the object. And then, when disappearing, reveal another object. Thus, morphing occurs. Before we move on to practice, let's sum everything up. First, you need to remember the 4 basic rules of good morphing and use them more often. The second is to study other people's animations, break them down, analyze other people's morphings, and try to recreate them. And the last thing is to combine methods. Make your animation look lively and more interesting. See you in the practical lesson.